Hi everyone, welcome to the Internship Studios session on AWS fundamentals. In this session, we'll be covering the fundamentals of the AWS cloud platform. AWS offers a diverse range of services including computing power, storage, databases, machine learning, analytics, content delivery, Internet of Things, security, and more. These services are designed to enable individuals and organizations to build and scale applications quickly and cost effectively without the need to invest in and manage physical infrastructure. So, this is the official definition of AWS, which is provided officially by Amazon Web Services according to their official documentation. We will dig deep into the definition and what it offers. We'll go through one line by line here. So, what it says, like apart from the first full form line, which as AWS stands for Amazon Web Services, we'll dig deeply into what it says from there on. So it says it is a comprehensive and widely used cloud computing platform. So comprehensive in the sense it offers like a wide variety of end-to-end solutions spanning from computing power and storage to machine learning and analytics. So it has a wide portfolio of services available at the fingertips to execute any like solution in our hands, and it's also a widely used cloud computing platform. So widely used in the sense, as you know, like it is also the current market leader in the cloud computing platform, like used by around 32% of the customers worldwide. So it also says it offers a diverse range of services including computing power, storage, databases, machine learning, analytics, content delivery, Internet of Things. So computing power in the sense it offers virtual machines, managed servers like Lambda. We have EKS, which is a Kubernetes based solution. And regarding storage, also we have many solutions. For example, S3, which is a world-class storage for keeping our front-end files for applications. For databases, we have Amazon Aurora, Amazon DynamoDB, and for machine learning, also we have many services which we'll see in our upcoming sessions. Analytics for data and machine learning workloads, we have that as well. For content delivery, we have various services. The Internet of Things. So you can see that it's a comprehensive service model. So also these services are designed to enable individuals and organizations in the sense like it can be leveraged by even a single person or a multi-million dollar organization which has around 500 or 10,000 employees as well. So it is for everyone to use, like they haven't uh, discriminated their use for only enterprise needs or something. So even a single individual based upon his needs, if you want to set up a business application, he can also take use of these services so that they can build and scale applications quickly. Build in the sense they can build their application using the power of AWS infrastructure, which is very global in scale. So, and also cost effectively, since we saw in the introduction to cloud computing session, like these cloud providers, for example, especially AWS, they have built these cost effective solutions. So, we don't have any upfront infrastructure cost that we should pay. We are only using as a rental solution from the cloud providers. We can use their existing infrastructure and we can only pay for the services that we use. So without the need to invest in and manage physical infrastructure, so we don't have that overhead of like if a server breaks down or a storage fails, so we can fix it up. AWS already has that covered for all our disasters, any disasters if it comes. Also, it's a collection of services. So the AWS cloud platform is a collection of services which creates a platform in the sense It's a one-stop solution which has like all the features built in. Like for example, we have the functionalities of virtual servers, networking, security, analytics, media services, and databases. So it's a one-stop shop, you can say, in simple words, for all the infrastructure related operations. And the third definition is also from AWS. So Amazon Web Services is the world's most comprehensive and broadly adopted cloud, offering over 200 fully featured services from data centers globally. Millions of customers, including the fastest growing startups, largest enterprises, and leading government agencies, are using AWS to lower costs, becoming more agile and innovate faster. As coming from the previous definition, this definition also says that it's the broadly adopted cloud. In the sense, it has been the number one cloud provider adopted by customers across the world, offering over 200 fully featured services. Fully featured in the sense they are ready to uh, like execute from the point we hit the click button. So they have become fully matured services. For example, EC2, like this, there are around 200 fully featured services spanning all the domains. So you can take use of all those services with the click of a button. Like with the power of, in the backend, they are powering those services with the help of their global infrastructure. So they have millions of customers, like many giant organizations. For example, Disney, Hotstar, we have. They are also on AWS. And also like even Amazon is itself hosted on AWS. Like the Amazon shopping app, in the backend it is hosted on the Amazon Web Service only. So if there are any sales or something, and even Flipkart is also hosted on AWS. So we can see like these applications are multi-million dollar revenue applications which are being leveraged up to their potential with the help of the cloud. So even like fastest growing startups, you can see the unicorns like Cred and all today, which are into the fintech industry. They are also leveraging these cloud platforms for their faster growth nowadays. And also the government agencies. Already gave the example of large enterprises like Hotstar, but coming to government agencies, like coming to the government agencies like AWS, they provide a dedicated solution called as AWS GovCloud, 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 which is designated to cater to the unique needs and stringent requirements of government agencies at various levels. For example, in US, they have this federal government, state governments, and local governments. So what AWS helps them achieve is they offer a very secure and compliant cloud computing environment that enables like government organizations to leverage benefits of the cloud while adhering to regulatory standards and security protocols. Because the main thing for governments to operate in the modern era is security and compliance. So what AWS really is helping is it's helping the governments to focus on meeting strict security and compliance standards required by government agencies. It adheres to regulations such as in US we have this FedRAMP, which is Federal Risk and Authorization Management Program, and we have ITAR, which is ITAR, which means International Traffic in Arms Regulations and others. So the AWS helps them create an infrastructure such that it's designed to provide a secure foundation for sensitive government workloads, because there's lot of data, like sensitive data, for example military data. So if it comes into the hands of like unforeseen agencies or any terrorist organizations, then it's very dangerous, right, for humanity. So the cloud, like AWS cloud, is also helping the governments here. Also, in the last definition, we have AWS, like government agencies are using AWS to lower costs, becoming more agile and innovate faster. So, becoming more agile and innovating faster, it refers to an organization's ability to adapt quickly to changes in its environment. It also helps to respond efficiently to evolving market demands, and they can introduce new ideas, products, or services very swiftly. So, the more agility also means adaptability. Like an agile organization can easily adjust to change in strategies, structures, and processes in response to changes in the business landscape. Also, flexibility. Cloud, like here, it powers flexibility options as well. So it involves the ability to modify operations, allocation of resources, and help the organizations pivot in a dynamic and unpredictable environment. So having cloud computing beside you also helps you make quick decision making also. Like agile organizations can empower teams to make decisions rapidly, avoiding bureaucratic hurdles and fostering a culture of autonomy as well. So innovating faster. So innovation, like cloud also fosters creativity here. So fostering a culture that encourages creative thinking and problem solving is essential for innovation. We also Cloud also helps in rapid prototyping as well. Like it helps in innovating faster, which often involves creating prototypes for a solution or minimal viable products quickly to test and iterate on ideas. It also helps in continuous improvement. So, since innovation is not a single time process, it's an ongoing process. So, constantly seeking like new ways to improve products, services, and processes is a very key component. So also it is fostering technology enablement as well, because AWS, since it is a very modern solution, it has very modern infrastructure. So having a robust and scalable technology infrastructure, like leveraging them, it can accelerate development and deployment process in a very faster rate. And also the decision making also, you can make it data driven, since everything is digital here. You know, like the numbers are coming. So leveraging data and data analytics tools, so we can allow organizations to make informed decisions and identify areas for improvement. I think you got a brief overview like of what specifically AWS cloud is. So we'll move to the next slide. Here the first thing is the pay as you go pricing model by AWS. So the pay as you go pricing is like you only use for the services which you use, and how much time, like what amount of time you are using those services for. This flexibility is paid by it's structured by Amazon for convenience of the customers, because it's very flexible and cost effective approach for cloud computing, because this model allows users to pay only for the computing resources and service they consume without the need for like upfront capital investment or long term commitments. So like the first main thing is usage based billing. So we have that 60-second minimum usage here, like whatever services you are using, you should use it for a period of 60 seconds at the minimum rate, after which you are started billing for. So AWS charges users like based on their actual usage of users and resources. Like users are billed for the compute power, storage, data transfer, or any other resources they consume. So here there are no upfront costs. Okay, so like users are not required to make any upfront payments or commit to a minimum usage level. There is a complete freedom upon you. So you can whenever go into the account, spin up a service, and whenever stop that and come out of the account. So this actually eliminates like the need for significant capital expenditures, and it also allows for your greater financial flexibility. Also here, the third point here is use 100 seconds and get charged for the same 100 seconds only, not a second less, not a second more. So this provides a very transparent option as well, because you already have that data coming in for how much time. For example, you spin up a virtual machine, so you have that view over how much time the machine has run. And here the two parties are very transparent here, like the user and the AWS here. So they typically offer, like for example, Amazon offers hourly or per second billing based on the service that you spin up. For example, AWS typically bills users on an hourly basis for certain resources like virtual machines. You mean EC2 instances. We'll see what EC2 is in the upcoming sessions. And also there are some other services which offer per second billing, allowing users to pay more granularly based on their actual usage. So here's like an overview of how the pricing actually works here. So we'll move to the next slide here. So as you already saw in the previous session, uh, in our introduction to cloud computing, so this builds upon that market share of the AWS in cloud computing space. So here it is a small snippet from Statista, which is a research group on cloud providers. So here it says Amazon leads $200 billion cloud market. So you can see it has clocked around 30%. So the data is for June 22 here, and you can see AWS here. It has a market share of 34%, more than 30%. One third of the cloud computing industry is commanded by Amazon Web Services. And in the second, we have Microsoft Azure, which is at 21%. So Azure is owned by Microsoft as the cloud platform. We have Google Cloud, powered by Google, which is at 10%. We have Alibaba Cloud, which is Chinese based. Uh, it is from Alibaba company, so they have their own cloud hosting platform. We have IBM Cloud, which is powered by IBM, uh, which is a full form for International Business Machines. It is also US based cloud company. We have Salesforce, we have Oracle Cloud, we have Tencent Cloud in the lower platforms. So you can see that the American companies are leading in the cloud computing market. You can see more than 50% of the cloud computing market share companies are from United States. So because since it's based on infrastructure, there is always demand. There is like companies and innovation are always innovating something. So you are in a very good domain actually. It's an ever growing domain for, I think, for the next 20 years, as I can see. Yeah, this is the market share of AWS. And in the next slide, we'll have an overview of like how the history of AWS is and how it came into existence. Actually, here the guy you can see, this guy is Jeff Bezos. You would have all, I think, I assume you have used Amazon application. So it's a $1 billion enterprise. Amazon is a very large company actually. They have various subsidiaries and companies under their belt across the world. So he's also one of the richest corporate persons in the world. So I think he is in the top 10. Uh, yeah, he's the brainchild of AWS. So its inception and launch, you can see it's around the year 2002 to 2006. So in 2002, AWS conceptualized to enhance Amazon's infrastructure. So Amazon was already existing as an online marketplace back then, but they, since they were scaling globally and there were millions of customers for it, so they gradually thought of like having their own infrastructure platform where they can host their applications. So in around that time, they visualized the concept of AWS. And in 2006, they had their first official launch. They offered services like S3. S3 is simple storage service. It's a storage service offered by Amazon Web Services, and we have EC2, which means Elastic Compute Cloud. So EC2 mostly caters to virtual machines. You can say like your computer. Just that it's an online virtual computer which is being set up in some AWS global infrastructure somewhere in some data center across the world. So in 2006, the official launch was made of AWS. Uh, in the second point, we have their early growth and milestones, which came around in 2006 to 2008. In 2007, they had the introduction of SQS and Simple DB, which we'll see in the later sessions what was the services are. SQS is SQS means a simple queue service, you can say. Like it's a fully managed message queuing service offered by Amazon Web Services. It enables decoupling of components of a web application, allowing them to operate independently and scale efficiently. Uh, and in 2008, expansion with services like RDS. So RDS is a Amazon relational database service. It's a managed relational database service. It's provided by AWS. It makes it very easier to set up, operate, and scale a relational database in the cloud. It allows users to focus on their applications rather than the underlying infrastructure. So there are some very popular databases which it supports. For example, MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server. So RDS came in around 2008. In 2009 to 11, they had a rapid expansion and global reach. So 2009, they introduced the AWS Management Console. So console, you can say it's like a handy UI. You can say you open Facebook, you have all the uh, like interface, right? We have the home button, we have my profile button, we have notifications. So you can imagine the console like the interface, like with what we can communicate with the application. So similarly, AWS, I'll show you the console in the later time shortly. And yeah, they came up with this console in 2009. It's like a web interface, you can say. And in 2011, they had this global expansion with new regions and availability zones. So regions are like for example, Mumbai. You can say Mumbai is a region. Currently, AWS has set up the region in Mumbai, and availability zones are separate data centers within that region. You can say. So I'll also explain you what these regions and availability zones are in the later slides. Imagine them as a location of the centers. That's it. And in the later years like 2012 to 2014, in 2012, AWS reaches 1 million active customers. So you can see they have introduced 2009 introduction of AWS Management Console. So within a span of 3 years, you can say they have reached 1 million active customers. So it's an amazing feat actually by Amazon. So by this, you can say that they have reached this global scale. Uh, and in the fifth point, we can see there is maturation and innovation. So 2015 to 17, they kept on adding more services. Like they have added Amazon Aurora. So I'll explain what Amazon Aurora in the coming slides. We have in 2017 over 90 services offered showcasing maturation and innovation. So they didn't stop on their success, though, so they kept on innovating and added more industry leading solutions to their portfolio. In the sixth point, we have this dominance and specialization. So 2018 to 2020, AWS in 2018, AWS maintains market dominance. So since from the conceptualization in 2002, they have been in the market for already 15 years. So they had this first more advantage compared to other cloud products. So they maintain their market dominance, and they have kept that until today. Okay, like even in 2023, the market share is with AWS itself. And also they expanded into specialized services like AWS Outposts, like in 2019. And the recent developments, like after the pandemic in 2020, you saw that there has been a digital disruption, and cloud computing has come to the forefront now. So there has been from 2020 on, there has been continued growth with services like EKS Anywhere. EKS is the Elastic Kubernetes Service anywhere, and in 2022 it's still there is ongoing innovation, partnerships, and contributions. For example, you can search the news and events like AWS reInvent and all. So across the year, there are some events and summits hosted around the world. So AWS keeps on innovating something new every day so that it can keep up with the changing times and have something new and exciting for the customers, which can provide value and growth always. So yeah, this was a brief overview of the history and what AWS is really at the present times. Uh, yeah, in this slide, we'll go through the popular services of AWS. So I have taken around 10 popular services which are like have become very popular nowadays in the aspects of cloud computing, and how businesses are leveraging all these core services. The first one here at number one is Amazon EC2. So Amazon EC2, it's a web service provided by Amazon Web Services that allows to users to run virtual servers in the cloud. Server in the sense computer which works as a server. So these EC2 full form is Elastic Compute Cloud. Okay, so Compute Cloud, there are two C's. So Amazon described it as EC2 for a simpler naming convention. So EC2 instances, they provide a scalable computing capacity. So they enable users to quickly scale up or down based on their application requirements. Yeah, this is the first. It's basically compute like provides a virtual server service. You can say virtual machine service. We have Amazon RDS here. AWS RDS. It's a fully managed relational database service. It's provided by AWS. So it simplifies your process of setting up, operating, and scaling a relational database. So we'll deep dive into all these services, like whatever I have taken. It's just for basic knowledge now. So I'll explain you in detail in the next sessions. So RDS actually it simplifies the process of setting up, operating, and scaling a relational database, allowing users to focus on their applications instead of managing the underlying infrastructure. So there are some key aspects to AWS RDS because it supports a wide variety of databases. For example, MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server. We have it also acts as a managed service. We have the specialties of automated backups as well. Yeah. So these are some key points about AWS RDS. And coming to the third core service, which is Amazon CloudFront. Actually, CloudFront is a very industry-leading solution. So it serves several critical needs for content delivery and web application acceleration. One major thing is it reduces latency. because since AWS has a global network of edge locations to cache and deliver content closer to end users, this reduces latency and ensures faster load times. For example, if we have like an application, for example, social media application Facebook, uh, so if people from India open the Facebook and try to load all the posts and all, so AWS makes sure that the data center is in India and users are actually diverted for their India location of data center, so that they get faster uh, upload and download speeds, or any like opening of and closing of the web pages in Facebook. So it helps in improved user experience, you can say, by the help of low latency. So the content is delivered from the edge locations to the nearest users, and hence CloudFront enhances the user experience. And we have the fourth number has Amazon S3 here, which is also a storage service. S3 is 3S in the sense simple storage service, you can say. So it's also a world class storage solution offered by AWS. We have Amazon VPC. VPC means virtual private cloud. So it's a networking solution by AWS. We'll dig into the later slides. So I'm just giving an overview here. And at the sixth number, we have Elastic Beanstalk. We have Amazon Lambda, which is a managed service to run your code. We have Amazon SNS. We have AWS autoscaling. We have both horizontal and vertical autoscaling. So the logo you can see. Sorry for that. The logo you can see that it's upward arrows, and there are side arrows as well. So what it states is it has the capabilities of both horizontal autoscaling and vertical autoscaling. So the Amazon has also used very creative logos, you can see here. So that uh, uh, a layman can also understand what the service is about. And we have the 10th solution as AWS Elastic Cache. Yeah, I think pretty much these are the 10 services and their logos respectively. So coming to the next one, I can show you that let's create an AWS account. So I think we have gone through a lot of theory till now. So it's up for a hands-on session. So some brief points, some notable points before we create an account. So the steps are we should first visit the AWS sign up page. We'll go to the sign up page. I'll show you in the browser. So then we need to click on create an AWS account. We need to provide your email address. Mm, the email address is very necessary here. So I suggest you people to have an email address handy with you. And then we need to enter the account information. For example, we need to fill your name. Like for personal users, your name will be suffice. And for enterprise needs, you should have your company name. We need to choose a very unique password, which is very strong, so that it's not very easy to know and be hacked. Uh, and yeah, we need to create an AWS unique account name. So rest is the contact information. We need to enter your phone number, which is working, and address of your residence. Also the payment information. We need to provide the payment details for identity verification. Normally it would be a debit card or a credit card. And identity verification. So we need to complete the phone call verifications. I think this is not required currently, because in the modern times just an OTP is required. So this phone call is not. I think it's mostly for business needs. And the next is a support plan. Since currently we are using the free tier account, we'll choose a free plan here. So paid ones are for enterprise accounts. And next we'll complete the registration by hitting create account and continue. So let's move on to the browser. Here is my browser, and I'll click AWS login. So yeah, here is the Amazon Web Services sign in option. Yeah, here we'll get a web page from the AWS portal actually in the browser. So you can see that how the AWS portal is designed, how interactively they have built this website. Actually, you can see the AWS reInvent, which is their flagship event in the year. It was hosted from November 27 to December 1 in Las Vegas in North Virginia. It says welcome to a new world of work with Amazon Q. So like for example, if we hit here Amazon Q, it says your generative AI powered assistants designed for work that can be tailored. So you can see there are lots of services coming each and every day, you can say. So there's always innovation in the AWS platform. So it's just a welcome note. And in the left side you can see it's the sign in options, the root user. I'll explain in details what all these are, but here for now you can ignore them. Root user is who, it's a like a superpower you have. He is the super user who has all the permissions for doing anything on that account. For current needs you can just understand like that. And IAM user is like a second level user, you can say. He doesn't have all the access. You just can fine tune whatever services that person needs to use. For example, in a company there are uh, developers, there are operations team. So for developers you can assign some specific permissions, and for other operations team you can assign some services user. So there are account ID or account alias you can use for the login purpose. But since here we are creating a new free tier account, I'll go to the create a new AWS account. So I'll also give a PDF for the detailed steps as well. So the first thing here we need is the root user email address. So I'll use my email address here. It's deadshot4341 at gmail.com. And we need to choose a name for your account. It says you can change this name in your account settings after sign up. So for the sake of signing up, we'll give something. So here I have given internship studio. I already have an AWS account, but for newbies who are trying to create their account for the first time, I'm showing how it is done. Uh, yeah. And the next step is you'll get a verify email address. So I'll hit verify email address. I will hit the they send this code actually to verify that it's actually you who are using. But in my case I'll not get the verification code since I already have fresh this thing actually. So for that there are some specific tests like steps that you need to follow. So what I would suggest is what I would suggest is just have a working credit card handy, and the number the credit card or debit card should be a Visa one, and you should have all those like the phone number should be attached to the credit card. Like it should be associated with the card so that there will be a, I think, payment of around 2 rupees that the Amazon takes care so that you are using a genuine credit card, because these cloud products, right, they are providing services worth lakhs and crores of rupees. So in case you spin up something very costly services, then they have that option to bill that to your account. So yeah, there are the two suggestions, and I'll attach a PDF as well at the end of the session. So yeah, so here let's navigate the AWS console and get an overview. So yeah, this is a bit kind of a, I think we have gone through lots of theory. It is essential to understand before we jump into the AWS. So yeah, we'll make this. I'll show you how the AWS console looks like here. So yeah, we'll go to the browser again. I'll hit AWS login. So yeah, I'm logging in as a root user since it has all the permissions. I'll hit my password. So yeah, this is how the AWS console looks after login. So yeah, this is the first thing is the search option that we have to search for any services that we want. Uh, let's go into the home. Uh, and here we'll sign into the console actually. Console is like a interface, you can say, which is like for example, you can say this, you have heard the terms of gaming console, right? So which makes everything interactive. So this is the way with which we can interact with the AWS services here. So you can say introducing my applications on AWS. It says now you can view metrics, insights and tasks for your application from across AWS all in one place. So they have this some kind of info here. It is the console home. You can see info here. It says console home displays widgets with important information about your AWS environment. So similar to widgets you have in your smartphones, right, to have some information handy. Similarly, you can customize your AWS console the way you want, actually by adding service related widgets. And here you can see the internship studio, which is the name of my account. We have this account ID, which is very specific for each account we create. We have this account details under this account. We have this organization. We have this service quotas. We have this billing and cost management, which is attached to your account. We have this security credentials for login and logout. And we have Sydney set as the location of my console currently. So these are all the regions that are available actually. Currently my account is set to AP Southeast 2, which is the current location, Asia Pacific Sydney it says. Sydney is basically a city in Australia. So Amazon has a data center in Sydney as well. So these are also nothing but these are regions actually. These are the locations at which AWS is operating currently, you can say. They are operating, you can say, these are the major locations that they have. They have in US East, North Virginia. So they have labeled it as US East 1. So they have US East Ohio. Ohio is a state. You have US West. You have North California. And in US West, we have Oregon as well. So if they have some similar, like in a region they have two data centers, they have named it as US East 1, US East 2, and similarly US West 1, US West 2 for easier naming convention. And in our India case, actually we have one in Asia Pacific. We have a region in Mumbai, Maharashtra. So they have named it as AP South one. AP here means Asia Pacific. So it's a short form for Asia Pacific. South means the location, like it's north or south, which direction it is residing, and one is the number of regions. Actually, if it has only one, they have mentioned it as tag 1. If they have more, then they can mention it as tag 2. One good thing is, since like the orange tableau, you can see that it's currently set to Sydney here. So I can already set to Mumbai if I want. And from here you can accordingly spin up any virtual server or any service from Mumbai location. So that's how interactive the location is. So if I want to set up the infrastructure in Singapore also, I can hit the Singapore button, and accordingly the console loads up to the Singapore location. So there are a couple of other handy features like settings. So under settings we have this language, so you can set up the language of your choice, like any English. Currently it's the default is English for me. You can set it to other languages like Indonesia, even Hindi. We have Espanol, we have like English UK, so we can configure the languages accordingly. And we have the browser mode, like in visual mode we have dark mode and we have light mode. So the browser default is set to the light mode currently. In the question mark here we have support center, which go takes you to the Amazon support center. We have expert help for any like advanced queries. We have repost. Let's see, repost is like a technical guidance. They all have this actually white papers and knowledge center. We have like if somebody has already faced any issue before, and they can go directly here and resolve any of the issues. And we have this documentation. So documentation means we have white papers regarding all the services, like these are the core services which I had showed you in the earlier slide. So you can deep dive and understand about each service by going into, for example, by EC2. By clicking on that we can have, like for example, wide variety of knowledge, how to interact with it, how to leverage it for various services, how to migrate it. So these are all advanced levels. I'll show you one by one. And yeah, and we also have this trainings. So trainings means there is already some knowledge base available from AWS that makes you like understand the services they are using. Some are free and some are on demand actually. Like some basic services are free for users, and some are like you should pay them for getting the training. So similarly we have getting started resource center for like having like any hands-on on any service you want. And send feedback means like if you are facing any issue with any service, you can send them a written feedback, then they'll look about that. And we have this notifications. It says welcome to AWS user notifications. It's a central location for your AWS notifications. In the AWS management console, notifications can be sent to email, mobile devices and chat channels. So similarly, like how you have this Facebook notifications, right? Any services you are using, like something happens to that, then you will get notified in this notifications, whether it has been deployed or whether it is running. It will show all in the notification section. And this is the Cloud Shell. Cloud Shell is like a programmatic interface, you can say. For example, you may have heard of a Bash terminal in your laptops, or you have heard of VS Code, Visual Studio Code Editor. which come as a very this interactive terminals, you can say. So similarly, Cloud Shell is for command line utility facility. So you can spin up any service using some commands instead of going and typing. So I'll also show you how AWS Cloud Shell works in the future sessions. And we also have search option here, like instead of, if you want to specifically want a service, for example EC2, I'll type, so it's coming here. So similarly S3 we have, I'll type S3, yeah, S3 we have. So yeah, similarly like any services you can get, type it here and use that right away. And here we have this small Rubik type box which says services. So recently, the first section is recently visited. Since we haven't visited any service yet, so it's blank for me. So there's an option of favorites as well. You can like keep any service as your favorite for easy access, and all services. So you can see the plethora of services that AWS offers. Actually, even I am not aware of any like services, because it's a mammoth of a platform, and there are like, for example, AWS Amplify, you can see, is a complete platform, frameworks and tools and app services for developing, building, testing and running mobile and web apps. There's API gateway, app mesh, AWS app runner. You can have app stream. So A to B, under B we have a couple of AWS batch, we have bedrock, billing conductor, C. So you can see there are 200, around 200 more services for each use case. And in the left, you can say the domain of what that service is meant for. We have like services for analytics like Amazon Athena, AWS Clean Rooms, Cloud Search, AWS Data Exchange. We have service for application integration. We have for blockchain, business applications, cloud financial management. For compute, we have this EC2, which are going to be our primary service for now. We have containers, we have customer enablement, database, developer tools, end user computing, and a lot of things. So we'll slowly get used to all the services. So yeah, there were a couple of services, and this is the AWS logo. Uh, and this is the console home, which says all services, my applications if you have something. And if you can scroll down slowly, we'll do this. It says welcome to AWS. If you're a first time user, it says get started with AWS, learn the fundamentals and find valuable information. So you can get started with, like, if you're a new user. So training and certification. So there are a couple of certifications as well. You can see from AWS they have this cloud practitioner, which is a entry level certification for people coming from non IT. We have solution architect associate, we have developer associate, we have DevOps engineer. So we have a lot of certifications to get your skills validated. Like once you enter the industry and get hands-on experience, right, you can showcase your expertise with the help of this professional certifications. And we have this takeover of what's new with AWS. So we'll have all the highlights. Like recently we had this reinvent of 2023, and how actually, like, what are the new services. So what's new in database, similarly what's new in featured security announcements. So in terms of cloud security, what all the announcements were made. So this is bit handy, like if you want to dive deep into those. So this is AWS health. So under info you can see that view events that might affect your AWS infrastructure that and account. So health in the sense, for example, since cloud is actually a physical data center somewhere, so AWS lets you know in advance. For example, in Mumbai, something like flood happens and the water got into the data center, and so all the like server related and other services will be on hold for that region. So in advance only, like if any disaster happens or some maintenance is going on for that data center, Amazon already sends you a notification actually, like your data center is going to be down for this much, and please replicate your environment or infrastructure somewhere else actually. So it's kind of handy and very informative, and so it helps us mitigate our downtimes effectively actually in times of applications. And this is the cost and usage info, like how much services you have used and how much cost it has like mm, used till now. Like it basically shows the billing details. So it says a build a solution, for example launch a virtual machine. Virtual machine means like a compute machine you can say. Register a domain. It has like all the solutions ready to go with these instructions. It takes around 2 minutes with EC2 to launch a virtual machine, start a development project, build a web app, deploy serverless microservices. So these are all the advanced use cases you can say. And this is explore AWS. So we have more lot of things to explore here. Amazon location service support is, as I already said, it's available here as well, the support center. Security info, we have this trusted advisor which gives some recommendations based on best practices that we can use in the console. This is the latest announcements. AWS always will be announcing something, like every day, every week there will be some advancement or innovation coming up, so they will be announcing this here. And these are the AWS blog posts. So blog posts are like good curated articles you can say, which helps, like there are some customers have already implemented something and they have implemented a solution. So if you think it's interesting, you can go to their blog portfolio and read all this stuff. So yeah, this is one handy solution. And also you can add widgets from here as well. So you can go to add widgets. So there are managed instances, op summary, patch compliance, and other solutions. So you can keep on adding, like customize however, like something you can, like the home screen of your phone lets you add widgets, right? For example, I need to operate a clock widget or some calendar widget. So accordingly you can customize this as well. So I think I have given you a good overview of how this console works. We'll move back to our slides for more info. Yeah, since we have navigated the AWS console here, so yeah, we'll understand more about what those AWS regions and availability zones were. So I had showed like in the console, currently we had like set the region to Singapore, right? So yeah, you can see this is the global map, and the orange boxes you can see, like we have Sao Paulo in Brazil, we have Oregon, North California, we have Ohio, we have North Virginia. These are all the regions, like these are global locations in the United States where the AWS infrastructure is located. And we have like in London, UK, we have in Ireland, we have in Sweden, Stockholm, in Germany, we have in Frankfurt, we have in Spain, we have in Milan, Italy, and in Brazil, in Sao Paulo, in South Africa, Cape Town, in Bahrain, in India, we have in Mumbai. So in China, we have a region in Beijing, in Japan, in Osaka, Tokyo, and in North Korea and South Korea. In North Korea, we don't have. In South Korea, we have in Seoul. So in Hong Kong, we have a region. In Singapore, in Indonesia, and in Australia and Sydney. So this is an overview. Like there are many more regions, since due to the like constricting, sorry, due to the available space we have, they have like mostly listed the major centers. And availability zones, like there are like in for example, we have this US West in Go Cloud, right? US West 1 and West 2, these are called as availability zones, which I showed previously in the console section. There are more such location things as local zones, points of presence, network, custom hardware, benefits, etc. So just think of regions as a global locations. So yeah, coming to the next slide, it says AWS regions and availability zones. So the first point is global presence. AWS operates in multiple geographical regions worldwide, including but not limited to North America, Europe, Asia Pacific, South America, and the Middle East. Each region consists of multiple availability zones to enhance fault tolerance and stability. So fault tolerance means like if in case like we'll go back here. So in case like we have this North California. So in North California is a region, and here we will have around 2 or 3 availability zones. So if actually one availability zone fall like fails, then you can move to another availability zone for fault tolerance workloads, because having multiple availability zones actually is always very good for security related aspects and business related aspects, because if you host an application in one availability zone, you can and that availability zone fails, so all your application will be down and there will be no customers, like they'll have a very bad problem of not accessing your solution. So this always have to have multiple data sensors to keep your applications highly available. So coming to the availability zones, each AWS region is divided into multiple availability zones, AZs in short form. So availability zones are essentially data centers within a region that are isolated from each other in terms of infrastructure and are designed to provide redundancy and availability. So all availability zones are like I think around hundreds of kilometers apart from each other for security purposes, and they are isolated because if you keep two availability zones in the same city, and if that city got flooded or some earthquake happens, so it will be very disastrous for that data center. uh, so it's always AWS thinks that it ensures that actually availability zones are well apart from each other so that they can always be used as a safe premises. So this is pretty much about regions and availability zones. So this is a small diagram. So here you can see the bigger circle is the AWS region, and in this three we have this data centers: availability zone 1, availability zone 2, and available zone 3. So these three region would be like something called North Virginia, and in North Virginia state we have all these three in different cities actually. So this is one location data center, this is second location data center, and this is the third data center. So these will be around hundreds and 200s of kilometers apart from each other for fault tolerance purposes. So coming to the core services of AWS here, we have this the first core service of AWS, which is the compute offerings. We have Amazon EC2. So EC2 So EC2 is a web service that provides resizable compute capacity in the cloud. It allows users to run virtual servers known as instances with a wide variety of instance types optimized for different use cases. Users have full control over the instances, including the ability to start, stop, and terminate them. So EC2 can imagine them as a virtual computer. So they enable like you to start, stop, and uh, terminate them at any time based on your use case. And we have this Amazon Lambda. AWS Lambda is a serverless computing service that lets you run your code without provisioning or managing servers. So you can see like managing servers here means it's managed by Amazon in the backend, so you do not need about which computer is running backend. You just need to write your code and that's it. Everything is taken care by Amazon. So with Lambda, you can execute the code in response to events such as changes to data in an Amazon S3 bucket, updates to a DynamoDB table, or HTTP requests via Amazon API gateway. So these are a bit of advanced use cases, but just keep in mind that Lambda helps you. It's like a serverless offering. Uh, Actually, it is hosted in the server in the backend, but just for since that you are not managing the server, it's called as serverless offering. So there are a couple of services like ECS, Elastic Container Service. It's a fully managed container orchestration service uh, that supports Docker containers. Docker is a DevOps tool which is used for application packaging by developers. Actually, ECS allows us to easily run, stop, and manage Docker containers on a cluster. Cluster in this sense is a Kubernetes cluster. So we'll see in deep what all these things mean in the future sessions. ECS can be integrated with Amazon Fargate, which is another AWS serverless compute engine for containers to run containers without managing the underlying infrastructure. We have Amazon EKS or Elastic Kubernetes Service. So EKS is a managed Kubernetes service that simplifies the deployment, management, and scaling of containerized applications using Kubernetes. So Kubernetes is a container orchestration service. Actually, it's actually founded by Google in around 2000s for orchestrating their in-house container service. So they were using a lot back from the start. So it allows us to run Kubernetes. So Amazon actually have made their service customizable to the AWS platform. So it allows you to run Kubernetes on AWS without the need to install and operate your own Kubernetes servers. So it's like a managed service, you can say. So there's a service called AWS Batch. So AWS Batch enables you to run batch computing workloads. Like batch means like at a time, like a huge amount of workloads. It automatically provisions and scales compute resources, and it optimizes the distribution of workloads across instances. So it keeps and scales the workloads accordingly according to the needs. We also have Amazon Lightsail. Lightsail is a simplified compute platform that is designed for easy use and quick deployment. It is suitable for smaller workloads and it provides pre-configured options for web applications, databases, and more. So Lightsail is often used by users who want a straightforward way to launch and manage instances without dealing with the complexities of a full-fledged EC2 environment. So EC2 is a very like customizable option. So from the starting from the name to the configuration of the instance, we are like configuring each and everything in the console. But Lightsail provides a simplified compute platform. Like you just hit a button and it will just deploy. Yeah, it's all about this compute offerings by AWS which are popular. So coming to the storage offerings, we have Amazon S3. S3 is like 3 stands for simple storage service. So we have three words starting with S. So Amazon made it like a point to make it easily readable as S3. So S3 is a scalable object storage service. Scalable means which will scale according to the needs of the user. Like if I want 100 GB or 1000 GB, you can scale to whatever storage you want. So it's a scalable object storage service that allows you to store and retrieve any amount of data from anywhere on the web. So it is designed for durability, availability, and scalability. So durable in the sense it's for long duration. For example, you can store it for years, hundreds of years virtually, or as long as like if you want it for a couple of days also you can do that. Availability in the sense the data is always available at your fingertips, and scalability you can scale according to the storage needs as well. So S3 is often used for backup like similarly what you take backup of your data in your phone, for example. like the already existing data is backed for somewhere secure, you can say. Archiving, content distribution, and data storage for web applications. So these are the use cases for S3. We have Amazon EBS, Elastic Block Store. EBS provides a block level storage volumes for use with Amazon EC2 instances. It offers high performance, low latency block storage that can be used as a primary storage for applications, databases, and other workloads. So EBS volumes can be attached to EC2 instances and are suitable for use cases that require persistent high performance storage. So just understand that EBS provides block level storage volumes for use with EC2. So you can attach them as an external SSD or HDD, you can say. So we'll deep dive into all these services. These are just for the definitions. So we have couple of these services as well. We have this Amazon Glacier. Glacier is a low cost storage service designed for archiving and long term backup of data. We have Elastic File System. So it's a fully managed file storage service that can be easily shared across multiple EC2 instances. We have Amazon FSx. It provides fully managed file systems that are compatible with popular file protocols. We also have AWS Storage Gateway. Storage Gateway is a hybrid cloud storage service that enables on-premise applications to use AWS cloud storage seamlessly. We have Amazon RDS, Relational Database Services. It was primarily known as a managed relation database service. It also provides options for storage as well. So RDS instances use Amazon EBS volumes for database storage. It also offers durability and high performance. So we have at last AWS Snowball. Snowball is a physical device that you can use to transfer large amounts of data, like petabytes of data for example, into and out of AWS. Like from AWS you want to transfer, or from external sources into AWS, it's made possible by AWS Snowball. So it's particularly useful when dealing with large scale data transfers that might be impractical over the internet. So there are some physical devices available from Snow family of devices, they say, from Amazon, which helps to transfer data. So yeah, coming to the networking offerings. So the first primary networking offering here is Amazon VPC, which is Virtual Private Cloud. So it enables us to launch AWS resources into a virtual network that you define. So it provides you with control over network settings, including IP address ranges, subnets, route tables, and network gateways. These are the components of the VPC. So it's the fundamental building block for your building your own isolated network within the AWS cloud. So you can say that that is the, like, it makes like a outer shell structure of whatever resources you deploy into the AWS. Like everything is set up in a virtual network. So another thing is Amazon Route 53. Route 53 is a scalable and highly available domain name system web service. It allows us to register and manage domain names and route internet traffic to the appropriate resources such as EC2 instances, S3 buckets, or load balancers. So if you have some xyz.com like domain setup, so you can redirect that domain for any resources you have, like any traffic, customer traffic that is coming, you can route that via this Amazon Route 53. And we have this Amazon AWS Direct Connect. So Direct Connect establishes dedicated network connections from your on-premises data centers to AWS. On-premise means a physical private data center owned by an organization. So this can provide more consistent network performance compared to internet based connections and can be beneficial for hybrid cloud architectures. So hybrid cloud means uh, cloud architectures consisting of physical, privately owned and public cloud setups. So due to compliance issues, some companies use this kind of cloud architectures. So these are some other popular networking offerings. AWS CloudFront we have. It's a content delivery network service that accelerates the delivery of your websites. APIs means application programming interfaces, video content or other web assets. So it distributes content globally, reducing latency and providing a better experience for end users. Like it's mostly useful for high performing web applications. So we have this elastic load balancing. ELB automatically distributes incoming application traffic across multiple targets, such as EC2 instances in one or more availability zones. It also helps ensure high availability and fault tolerance for our applications. We have Amazon via AWS VPN. So VPN services such as site-to-site VPN, client VPN allows you to establish secure connections between your on-premise, you mean your physical data centers, private, and your VPC or remote users. So we have this AWS Transit Gateway. So Transit Gateway simplifies the connectivity between VPCs and on-premise networks. On-premise means a physical data center network. So it acts as a hub and you can use to connect multiple VPCs from the AWS cloud and your physical on-premise network as well. So we have this Amazon Elastic Network Interface. ENIs are virtual network interfaces that you can attach to instances in a VPC. Instance you mean a virtual server. So they allow instances to communicate with each other and provide additional networking features such as multiple private IP addresses, elastic IP addresses, and MAC addresses. So similarly, we have another networking service called AWS Private Link. Private Link enables you to access services over an AWS VPC endpoint rather than over the internet. It enhances security by keeping traffic within the AWS network and avoids exposure to the public internet. Thereby, like you can leverage this for security related aspects. So next we have the database offerings. We have the primary one is the Amazon RDS, which is relational database service. So RDS is a fully managed relational database service that supports multiple data engines including MySQL, PostgreSQL, MariaDB, Oracle, and like Microsoft SQL Server. So it automates routine administrative tasks such as backups, patch management, and failure. So we have most of the open source databases uh, compatible with this managed service. We also have this Amazon DynamoDB. DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. It is suitable for applications that require single digit millisecond latency for read and write. So it supports high high performance and read and write operations, and it also has a very low latency for enterprise applications. Similarly, we have Amazon Aurora. So Aurora is a fully managed relation database engine compatible with MySQL and PostgreSQL. It offers performance and availability similar to commercial databases that we have, for example, Oracle databases, but at a fraction of the cost. So, like compared to the commercial databases, the cost in borne by AWS is very low actually due to its huge mammoth infrastructure. So Aurora automatically replicates your database volume across multiple availability zones for high availability and fault tolerance. So this Amazon Aurora also you can leverage for disaster tolerant applications where you have the need to be having the application always running. So similarly we have this other options such as Amazon Elastic Cache. It is also fully managed in-memory data store service compatible with Redis and Memcached. It is used to improve the performance of web applications by allowing you to retrieve information from fast managed in-memory data stores instead of relying entirely on slower disk-based databases. So it also comes as a fully managed service. So we have Amazon Neptune. It is also a fully managed graph database that supports popular graph models including property graph and RDF. So it is designed for building applications with highly connected data sets such as social networks, fraud detection, and knowledge graphs. So we have DocumentDB. DocumentDB is also fully managed MongoDB compatible database service. It is designed for handling JSON like documents. So JSON is full form of JavaScript Object Notation. So it's a language similar to YAML we have in Kubernetes. It provides scalable and flexibility of a NoSQL database with the functionality of a fully managed relational database. So we have Amazon Redshift. Redshift is a fully managed data warehouse service that allows us to run complex queries on large data sets. So if you have large data sets, we can make use of Amazon Redshift. So we have Amazon Data Migration Service. Data Migration Service is a service that allows us to migrate databases to AWS easily and securely. For example, if we want to migrate from on-premise to AWS or from other cloud providers like Azure or Google, you can leverage the database migration service. So it also supports homogeneous migrations, means same vendor migrations, for example Oracle to Oracle, or heterogeneous, means like alike services, cross vendor migrations from Oracle to MySQL. So I also have this Amazon QLDB Quantum Ledger database, which is more suitable for this blockchain related operations. We have QLDB is a fully managed ledger database service that provides a transparent, immutable, and cryptographically verifiable transaction log. It is designed for applications where an authoritative and tamper-proof record of all changes to the database is critical. Mostly like blockchain-related applications, you can say. Yeah, like we have finished like the core services of AWS and what their different use cases are. Uh, Here, another basic point we need to understand is, as part of the fundamentals of AWS, is the AWS well-architected framework. So the overview of the framework according to AWS is the AWS well-architected framework describes key concepts, design principles, and architectural best practices for designing and running workloads in the cloud. By answering a few foundational questions, learn how well your architecture aligns with cloud best practices and gain guidance for making improvements. Actually, the main goal of the well architected framework is a set of best practices for building secure, high performing, resilient, and efficient infrastructure for applications on AWS cloud. Actually, it provides a structured approach for architects and developers who are designing on the cloud to evaluate whether their architectures and implementing design principles align with the AWS best practices. So the framework consists of these pillars, actually a set of pillars they have, each focusing on a key aspect. For example, we have this operational excellence, so run, manage, and monitor production workload to deliver business value, and continuous improvement on supporting process and events. So this operational excellence pillar has a set of procedures and instructions so that how you can design on the cloud. Basically, we have another pillar called security. So this explains on protecting information systems and assets along from outside world with risk assessment, unplanned failures, and mitigation strategies. So we have the third pillar as reliability. So reliability means like how fast we can revert back our setup in case of a failure. So how reliable the services should be operating on AWS. So it helps us to design to auto recover workloads from infrastructure, power or system failures with dynamic resource management to meet operational threshold. So the next pillar we have performance efficiency. So we can gauge how much the computing resources have been taking and how efficient they are operating on the cloud to support on demand changes for delivering workload with maximum performance to meet the SLA. SLA means the service level agreement provided by AWS on a service, that how much availability that service should be running in a year. And the last pillar is the cost optimization, which is a very important one. So it helps in avoiding and eliminate unavoided cost or replace resources with cost effective resources without impacting the best practices and businesses. So since we are in the cloud, cost is a major thing. It's a major driver for digital growth. So we need to keep an eye on how much the resources are utilizing and what time and how much amount of money they are panning it out. So yeah, it's always helpful to optimize costs as well. And the next important thing is the AWS shared responsibility model. Because shared responsibility means here the responsibility of our operations in the cloud is shared. So the blue box you can see, uh, it is the responsibilities of the customers, and the orange ones you can see it's the responsibility bear by the AWS. So you can see that the customer is responsible for security in the cloud. So the in is in the inverted commas. So for example, when I enter into the AWS account, whatever I do, it's the responsibility of my own, because here I'm acting as a customer for AWS. So I'm spinning up some resources. So I'll be responsible for whatever I'm spinning up inside the cloud. So for example, the customer data, the platform applications, IAM, operating system, network and firewall configuration, client side data encryption and data integration, server side encryption, network trafficking protection. So these are all the aspects which are needed to be taken care by the customer, you mean ourselves, once we enter into the cloud. So AWS will not have a say in what we'll be doing and what configurations we'll be handling. So AWS in this orange box we can see they are responsible for security of the cloud. Means for example the whole infrastructure they are setting up in the back end. For example the data centers, the compute offerings they are offering, the storage offerings, the database offerings, the software related licenses and other distributions, the networking setups, all the hardware and whatever the infrastructure they have, they will be responsible for the security and the upkeepment of all those services. For example, all those things are hosted in regions, availability zones, and edge locations. So AWS is held responsible for security of the cloud, not in the cloud. So whatever do inside the cloud, it's for the customer, and whatever the outside of the cloud, like the physical infrastructure and the upkeepment of the services, it will be held by AWS. So this is an overview of the shared responsibility model where it's a gel of both customer and AWS you can say. So yeah, thanks for attending the session. It was pretty much all about like the summary I can say. So whatever the topics that were covered here, like we saw the AWS fundamentals, the core services, for example their compute, storage, networking and database related services. We saw how the regions and locations are there, like what locations the currently AWS is operating and what are regions and availability zones, those aspects. uh, we knew how the account creation of AWS is done, and I also walked you through the console of the AWS and how the AWS console looks. I also gave an overview of the well architected framework, the shared responsibility model. Hope you got an overview of all the fundamental knowledge. And in the next session, we'll be discussing about the AWS identity and access management. So that is going to be the first session on getting into the AWS services. So we'll discuss deeply on all the services about that. So once again, thank you for attending the session and hope we'll meet in the next session. Thank you.